Today we're going to wrap up with backpropagation. So we already know pretty much everything we need to know about what happens in the neural network. We know that there is a process called forward propagation where information is entered into the input layer and then is propagated forward to get our y hats, our output values. And then we compare those to the actual values that we have in our training set, and then we calculate the errors. Then the errors are back propagated through the network in the opposite direction, and that allows us to train the network by adjusting the weights. So the one key important thing to remember is that backpropagation is an advanced algorithm driven by very interesting and sophisticated mathematics, which allows us to adjust the weights, all of them at the same time. All of the weights are adjusted simultaneously. So if we were doing this manually, or if we were coming up with a different type of algorithm, then even if we calculated the error and then we were trying to understand what effect each of the weights has on the error, we'd have to somehow adjust each of the weights independently or individually. The huge advantage of backpropagation, and this is a key thing to remember, is that during the process of backpropagation, simply because of the way the algorithm is structured, you are able to adjust all of the weights at the same time. So you basically know which part of the error each of your weights in the neural network is responsible for. Now, that is the key fundamental underlying principle of backpropagation, and this was why it picked up so rapidly in the 1980s, and this was a major breakthrough. And if you'd like to learn more about that and how exactly the mathematics works in the background, then a good article which we've mentioned already is The Neural Network and Deep Learning, a book by Michael Nielsen. You'll find the mathematics there written out, and it will help you understand how exactly this is possible. But for now, for our purposes, from an intuition point of view, the important part is to remember that that's what propagation does. It adjusts all of the weights at the same time. And now we're going to just wrap everything up with a step-by-step walkthrough of what happens in the training of a neural network. So step one, we randomly initialize the weights to small numbers close to zero, but not zero. We didn't really focus on the initialization of weights during our lectures, but the weights have to start somewhere. And they are initialized with random values near zero. And from there, through the process of forward propagation, back propagation, these weights are adjusted until the error is minimized, till the cost function is minimized. In step two, input the first observation of your dataset. For the first row into the input layer, each feature is one input node. Take the columns, put them into the input nodes. Step three, forward propagation from left to right. The neurons are activated, and the impact of each neuron's activation is limited by the weights. So the weights determine how important each neuron's activation is. Then propagate the activations until getting the predicted result, y hat. So basically, you propagate from left to right. You'll go away until you get to the end and you get to your y hat. Then we compare the predicted result to the actual result, measure the error. Then you do the back propagation from right to left. The error is back propagated, and then we update the weights according to how much they are responsible for the error. Again, you're able to calculate that because of the way that backpropagation is structured. The learning rate decides by how much we update the weights. Learning rate is parameter you can control in your neural network. Step 6, repeat steps 1 to 5 and update the weights after each observation. That is called reinforcement learning. In our case, that was stochastic gradient descent. Or repeat steps 1 to 5 but update weights only after a batch of observations, called batch learning. It's either full gradient descent or batch, or mini batch gradient descent. And step 7, when the whole training set passed through the network, that makes an epoch. Redo more and redo more epochs, and just keep doing that, and allow your network to train better and better, and constantly adjust itself as you minimize the cost function. So there you go. Those are the steps you need to take to build your ANN and train it. And these are the steps that we will take together in our practical demonstrations. Wish you the best of luck, and I look forward to seeing you in our next lecture, which is the actual presentation of how to build the ANN.